I want to do a couple of examples of using InvNorm on the calculator with any normal distribution. InvNorm, the question will be, they'll give you an area or a percentile or cutoffs, and that's when you'll use InvNorm. In this example from the homework, they say that 0.85 is the area to the left of this particular x value. They want you to find the x value. InvNorm can do that. So the mean and standard deviation are 115.85 is the area to the left. So on the calculator, I'm going to go to distributions, InvNorm, which is number 3. Okay, my stat wizard is on, so the area is asking me for the area to the left, which I'm going to review. What was it? It was 0.85. It's 0.85. And then you have to enter the mean and standard deviation. Let me double check those numbers. It was 100 for the mean, 100 for the mean, and 15 for the standard deviation. And then I'll hit paste. And this is what you would enter if you didn't have the stat wizard on. 115.5465. Let me see how they want that number represented. What do they want? 1 decimal place. So to 1 decimal place, 115.5. 115.5 to 1 decimal place. 115.5. 115.5. Check answer. Nice work. Okay, now this one is sort of the opposite in the sense that here's the x value and 0.97 is the area to its right. Now, under any normal distribution curve, the total area under the curve is 1. So if 0.97 is the area to the right, 1 minus 0.97 is the area to the left, and that's what I'm going to enter into InvNorm. It still has a mean of 100 and a standard deviation of 15. So if I go back to InvNorm, the area is area to the left, and I'm just going to double check to make sure I have the right numbers. It's 0.97, so it's 1 minus 0.97 is what I want to enter for the area. 1 minus 0.97, and the mean and standard deviation are still 115. So when I do that calculation, again, if without the stat wizard, this is what you would enter directly. 71.78. How many decimal places do they want for this number? 1 decimal place. Let me look at it again. 1 place, 71.8 if I round that off to 1 place. 71.8. 71.8. Check answer. Fantastic. I think I should try to write those in. All right, anyway, let's see that. That looks like a normal CDF. That looks like a normal CDF. Okay, here's a good one. So they give you a mean and standard deviation, and well, let's do this. It says find the percentage of women meeting the height requirement between 58 and 80. This is back to a normal CDF, which 58 and 80. I'm writing these numbers down, and the mean is 63.6, and the standard deviation is 2.3. So the first part of the question, the percentage of the women who meet the height requirement, is normal CDF between 58 and 80 with a mean of 63.6 and a standard deviation of 2.3. I'm going to have to answer the question as a 2 decimal place percent. So I'm going to go to the calculator, and I'm going to go like this. I'm going to go normal CDF, and the lower value, I wrote it down as 58. The upper value is 80. The mean is 63.6. Let me check that. 63.6 and 2.3. Okay, 63.6 and 2.3. 63.6 and 2.3. Okay, so this gives me 0.992549. Now they want this as a two-place decimal percent. One way I could do that, I can see as a two-place decimal percent is going to be 99.25%, but if changing fractions to decimals to percents and rounding them off isn't your thing, I can do this. I can go like this, math, num, and then I'm going to use the round function, round, and then I'm going to take that number 0.99254963. Now that's the decimal. To convert it to a percent, I'm going to multiply it by 100, and then I'm going to round it off to two decimal places, comma, 2, close the parentheses, and that gives me 99.25. So that's, I hope that's what they want, 99.25. 99.25. Check answer. Well done. Now the next part, this is, are many women being denied? No, it's a very small percentage. Let's see. Yes, no, there are not many women being denied if 99.25% are being accepted. Are many women being denied? No, because the small percentage are not allowed. Okay, so that's B. Sometimes those questions are hard to figure out. Okay. And now this is the InvNorm thing. So they want the shortest 1%, the cutoffs for the shortest 1% and the tallest 2%, with, remember, the mean was 63.6 and the standard deviation was 2.3. So here's where I'm going to use InvNorm. For the shortest 1%, I'm going to go to, let's turn the stat wizard off. So it's just so you can see what happens with InvNorm when the stat wizard is off. Let's see, enter, second, quit to get out of there. Okay, so now for the shortest 1%, 1% is 0.01 as a decimal. So I want to do InvNorm. InvNorm, for the shortest 1%, the area to the left is 0.01, and the mean, comma, the mean was 63.6, 63.6, comma, and the standard deviation was 2.3. And when I enter that, I get 58.249. Now, how do they want these numbers? Should I wait till I get the other one? Okay, so yeah, at least, okay, so that's the first thing. At least it should be 58.2 rounded off to one decimal place. So for this, I want at least 58.2. And the other one is they want the tallest 2%. That means 2%, which is 0.02, is the area to the right. So 1 minus 0.02 is the area to the left. So for this one, I'm going to do InvNorm. InvNorm. Whoops, wrong thing. I guess I'll just clear that. Distributions, InvNorm. I'm going to go 1 minus 0.02. That's 98% of the area is to the left, 2% is to the right, comma. The mean is 63.6, and the standard deviation is 2.3. Close the parentheses, and I get 68.3 to one decimal place. 68.3, 68.3, and let me check this. Excellent.